Part 2. K3-Tent envelope. Lesson 4. 1. The meaning of frame grid object and its structure. 2. How to create the frame object for real structure. 3. Boundary conditions. And 4. Practices. Fabric tensile structures are difficult to draw and harder still for the clean to visualize. Therefore, a stage of preliminary design usually precedes a structure analysis in details. The preliminary design of tension structures involves the determination of an initial configuration referred to as form finding. In order to make this process much easier, the special frame and grid model was developed. This model consists of two parts, which are the frame object and the grid object. The grid object is the child of the frame object. It means that if we change the frame object geometry, we can obtain new optimal form of the grid object automatically due to the special, very efficient relaxation technique based on the stretched grid method. Actually, the frame object is a template for the tensile fabric structure to be designed. It consists of a set of vertices and edges. The edges can either be straight lines or circle lines. The frame object is mathematically a graph with circuits. A set of circuits corresponds to a tensile fabric structure patches. Typical frame objects is shown in this slide. The frame vertices usually meet either the points of the close hitch to the tent or the points at which the close patches should change their geometry. The frame edges are the subject to define depending on two criteria, namely the changing of fabric close geometry, for example, and fabric close boundary constraints. Okay, let's create such frame for the cone tent with a hexagonal base. First, we use the function of K3 system that we already know. I mean K3 create lines and primitives. We create hexagon by the function K3 create primitives polygon. In the lower menu, we define number of sides and print 6 in the command line. Press enter. Then we type 0, 0, 0 in the command line and press enter to define the center of hexagon and type the coordinates of the key hexagon vertex, that is 6000, 0, 0. Okay. The next step is to create the circle with the center in origin 0, 0, 0 and radius 2000. Create lines circle. In the command line, we type the 0, 0, 0, press enter, and type 2000 and press enter. Okay. Then we create 3 lines crossing the opposite vertices in the hexagon. That is, one line down, second line down, and third line down. Using the command edit cut outer, we remove parts of the lines inside the circle. That is, okay. Now we have to break the circle by the lines in the points of intersection by command line break edit, break, alter. That is circle, and we have to mark all the lines that we want to break our circle. Done. Okay. Now our circle is subdivided into 6 arcs. To move the circle to the top of the tent, we use the command conversions movement in node duplication mode. Select the circle by the rectangle tool. Yes. Press subcommand done. And define the movement vector. That is 0, 0, and 6,000. It means that 6,000 millimeters is the height of our future content. Press enter. Okay. Now we have such situation. The last step is to edit lines, connecting them to the circle with the snap tool to end. We make it like this. Edit line and using snap tool to end. I'm sorry. It's the wrong point. We should make it very carefully. Okay. And that's all. Our draft frame is ready. Now we have to register our frame object by the special command. K3-Tent uses the following 3 command groups: form finding, pattern, and information. Form finding group is used to create an edit frame grid object and relaxation including. Pattern group consists of command for cutting patterning. Information group is intended to obtain information about a tensile structure. First, we use command form finding framework create. Upon the command request, we have to choose all mode. However, not all the segments in the structure are blinking. It means that not all of them have status line. Let us check it by the command K3 info object type. Okay, the segments at the frame base have status polygon. Remember, that is the structural object and we have to ungroup it. Select the command K3 structural operation, ungroup, and mark the hexagon and press done. Okay, now we are ready to register our frame object. Select command form finding framework create once again and press all mode. Done. And now we have to answer upon the request of the system yes or no to register our entire frame patches. Remember please, we should answer yes if we're absolutely sure that current patch is a part of fabric clothes. Yes, yes, yes. We can do it either in this menu or press enter button to answer it in the command line. Yes, yes, yes. Finally, The system shows the direction of normal vectors to the future structure surface. If it's OK for us, we press Done. If no, we press Reorient. It has the same effect as Done, but the normal vectors are changing their directions. Now, that's all. And we can do further steps. The fabric cloth of a tensile structure obviously needs to be attached to the supporting structures on hull. Therefore, the proper kinematic boundary conditions should correspond to each edge and each vertex of the frame object. There are two principal approaches here. A continuous fixed edge, for example, the circle, or a scalloped edge with attachment points just at the corners. The scalloped edge incorporates a fabric pocket through which a supporting cable is run. The assumption mentioned above results in three types of edge boundary constraints. First, freely deformed edge. This edge has status free. For example, edges AB, BC, BE, DE, EF. Second, fully constrained edge. This edge has status fixed. For example, edges CF and AD. Third, the status of edge may be also elastic. Elastic status is something average in between free and fixed. Similarly, vertices can have three types of boundary conditions too, namely free vertex, fixed vertex, and elastic vertex. The third type allows simulating cables to stretch fabric close. Now let's define boundary conditions to edges of our frame. To make it, we use the function form finding boundary conditions. Let's define the boundary conditions to the arcs edges at the top of our tent. Mark it and press Done. We define the status fixed for these edges. To define the status to lateral edges, we mark them and press Done. As you can see, these edges can have status free by default. And finally, we define the status elastic to the edges at the base of our tent. To define the status elastic, we should define the elasticity ratio that can have the value from 0 to the value indefinitely large. 0 value corresponds to the free status, and indefinitely large value corresponds to the fixed status. We define, for example, 2 or 3. 2. Okay. And now we can create the final tent. To make it, we use the command form finding surface create. To create the tent, we should mark the frame and define the ratios in this table. However, we create the tent now using all the ratios by default. Okay. As you can see, the first step is the draft grid of the tent, and finally we can obtain the tent of such form.